Thank you, Jan. There we go. We started our firm about 3 years ago after we left SOM. And at the time we were at SOM, we were very interested in the idea of creating buildings that would be as close to zero energy, zero carbon emissions as possible, such as the Pearl River Tower in Guangzhou. And so when we started our firm, we continued to think about structures and buildings in that way, meaning very highly sustainable pieces, but pieces that would actually harvest the forces from the site, from the wind, from the sun, and from geothermal. And this is an example of a prototype building that we did when we first started the firm and had no work. This was a competition called the Masdar headquarters in Abu Dhabi, which we won. And this building is about 1 million square feet on 8 floors. And this building is under construction now, and so far it is positive energy by 3%. So it means that this building is generating more power than it uses, and it puts in 3% of that power into the grid for other buildings to use. We then were commissioned to look at Sears Tower, but not the tower itself. It was the initial commission was for the adjacent site, where the Willis owners discovered that there were foundations under part of the plaza that would support a portion of a hotel. So they asked us to investigate this, and we did. Along with that, we were starting to investigate the amount of area that could be accommodated on that site, not only from a structural point of view, but from a zoning perspective. And as we got into the project, we started looking at Sears Tower itself, or Willis Tower itself now. And we started looking at the exterior wall, and started looking at a lot of aspects of Sears Tower in terms of how much energy we could reduce in the Sears Tower. Since it's approaching 35 years old, many of its systems are at a point where they will need to be significantly refurbished or replaced. And through the process of looking at the exterior wall, mechanical systems, daylighting, green roofs, water savings, operations and maintenance, solar hot water, wind turbines, and vertical transportation, we discovered that we can actually conserve more than 68 million kilowatt hours per year by a prudent development of each of the systems. So we also understand that Willis Tower is a significant resource in the city. You're not going to just tear it down, but it was approaching a standard of office building that was not Class A. And as such, if you leave it to deteriorate, you reduce the amount of rent you can get on the building, you reduce the investment income that can be attributed to the building, and slowly but surely it depreciates and becomes a liability to the city rather than an asset to the city. So part of this issue is how much embodied energy do we save by not tearing down this building and doing another 4 million square feet someplace, and the amount is a great deal, so as you can imagine. So after we looked at this building and we studied the amount of energy that we could save, which was substantial, and really began to understand the various systems involved, and I'm clicking through this fast because I have about 90 slides here. We started looking out of our windows in our office buildings and that we were occupying, and said, what does this tell us about the rest of the city? And so we decided to go through and develop a scenario or a case study on the rest of the buildings in the central area of Chicago. And By the way, this was the scheme we came up with, the hotel adjacent to Sears Tower, which is in for planning permission now. The hotel has sky decks, it has solar hot water, it has a high-rise series of roof gardens. It has wind turbines integrated into the facade to take advantage of the wind forces that are coming from the southwest and hitting the building, and it's speeding up as they hit the corners of the building. It has a very high-performance exterior wall, possibly a double wall. It has urban gardens in the sky. It has cultural exhibits. It has physical plants that optimize and share the energy efficiency between Sears and itself, or Willis and itself. And then it energizes the public level at grade with art walls and retail facilities wrapping around the entire complex. Just thumb through these fairly quickly. So the high-performance energy works really well with office and hotel combined on one site. There's an excellent opportunity to share the energy and other systems between the two. There's a real synergy between these two buildings that happens. So we started becoming aware, acutely aware of climate change, and looked at the 2030 challenge, which talks about fossil fuel reduction and a standard for all new buildings and major renovations for other buildings, and noted that in 2020 there needs to be an 80% reduction in carbon emissions for these buildings. That's only 10 years away, 80% reduction. The BOMA 7-point plan challenge is a little more lenient. It's a 30% reduction by 2012. And the Chicago Climate Action Plan calls for a retrofit of half of Chicago's commercial and residential buildings to a 30% reduction in energy by 2020. But the one that's most often cited nationally and internationally, and one that Mayor Daley has signed on to, the pledge of 2030 challenge, which effectively says we should be at 80% reduction in the next 10 to 11 years. So what does that mean to all of us? You know, those are numbers. They're nice numbers, but who knows how much that is? So we started to do a district study, and we said, let's look at the Chicago Central Loop, the area basically from south of the river on the north, east of the river on the west, Congress Avenue on the south, and about 2 miles out into the river on the east. That was our study area. This area is 460 acres. It has 120 million square feet of built space in it, and its total carbon emissions today is roughly 3.9 million metric tons of CO2 per year. So 3.2 million metric tons per year. How much is that? That actually, in order to satisfy that need, and what this chart shows is 80% of that need, which is 3.12 million metric tons per year of emissions reduction, which would satisfy the 2020 guidelines for the 2030 challenge. We did a little analysis. We did some analysis. We found out that you would need 90,000 acres of large wind turbines, 600 of them, to produce 3.12 billion metric tons. So 90,000 acres could do that. It was somewhat less in terms of photovoltaic. You could take about 40,000 acres, I believe it is, of area of photovoltaics in this area. But the actual cost of these is pretty significant. The 90,000 acres of turbines would cost you roughly $2.7 billion, and the equivalent energy, clean energy cost for all photovoltaics would cost about $24 billion. So you get a sense of the order of magnitude, how to decarbonate that central area. That's what it would take if it's just done by clean energy on the grid. Go back to this other slide for a second. What we did, though, is we started to look at the city in terms of components. And the first component in this chart, the orange component, represents how much energy could we save, how much carbon could we reduce if we did effectively the same thing we're doing to Willis Towers to every building in the study area. That would satisfy about 30 to 35% of our need. That's a huge undertaking. It's about a $6 billion undertaking. But before we did that, we started to think about an energy model for the city, for Chicago Central. And we took the city of Chicago, we sent about 50 people out to inventory each building in the study area, which you see here. And we categorized the buildings by carbon footprint, how much carbon per square foot, how much kilowatts per square foot, how many therms per square foot, what's the parking in the building, how old is the building, how big is the building, and what are its uses. And we created a database that shows each of these conditions. The colored drawing here shows the red is office, the yellow is residential, and so on. So you see the mixture of the central area is mostly office on one side and a little tag of residential on the other. We also looked at the biggest buildings and color-coded them. And within each of these buildings, it's a live model, so you can hit your computer point on any one of these buildings and find out how much square footage there is in each building, and how old the building is, and how much carbon there is. So this shows the actual total carbon per building per square foot in these buildings in the study area that are emitted. And then this one shows the energy use and intensity, how much energy is actually being expended from the point of view of electricity. 22 million kilowatts per year. The building era we thought was important to study, and we categorized this in 4 different categories, which I'll get into just a little bit. And then we started thinking about how would we go about attacking a more comprehensive plan for decarbonization of the central area, study area. So we first said, let's take a look at the biggest buildings in the loop and how much would they, those are the big targets. That's the low-hanging fruit, so to speak. You can get the biggest bang for the fewest buildings. Also, we looked at the government buildings and said, okay, those are owned by an entity that wants to reduce carbon, so let's look at those buildings and see what we could do with those. We also thought about districts such as the LaSalle corridor or any major corridor as a study area, because these buildings have a relationship to one another, and through a number of criteria we might be able to do better combining them than to do each one separately. We also looked at the age of the buildings. The heritage buildings from 1880 to 1950 all represent a block of buildings that are pre-air conditioning. So most of these buildings have operable windows. Most of them have shorter lease spans. They have natural light that feeds back into the space, and you can see where they're located on the map. These are buildings, many of these are still used for office buildings, and later on in the study we talk about how these could be converted to residential. We then looked at the mid-century buildings, 1950 to 1975. This stock of buildings represents a pre-energy embargo, but air-conditioned, central air-conditioned buildings. So at this time, there were glass curtain wall systems. The glass percentage was sometimes 50 to 80%. Mechanical plants had large heating and cooling capacity to overcome the internal loads. Heat by light was very common, and large floor plates and central cores were common. So this is a particularly important study area in terms of where we can conserve a lot of energy and carbon in the future. The post-energy crisis, 1975 to 2000, these buildings by and large have been designed with an energy consciousness in mind. And the current era, 2000 to present, I categorize these as the LEED awareness buildings, where developers in particular are seeing that if they get a LEED certification or a LEED Silver or LEED Gold, sometimes their space is more valuable on the market and they are able to justify additional expenditures in their buildings to achieve a LEED certification to achieve a little more rent. So here we are back at Cleantech Tower, utilization and harvesting the wind. And the study area, we have identified 86 million square feet of buildings that are controlled by something like 20 entities in the study area. So we are in the process of going to each of the owners of these entities or managers of these entities and interviewing them about their building to get more detail about exactly how they're used, who's their tenant mix, are they full or not, because when you get a number from Commonwealth Edison that says you use this much power, that's fine, but is the building full or half empty? It really has an effect on how much per square foot power you're using. And then we, on Sears Tower and on all of these buildings, we could evaluate these on the basis of their envelope, and we've thermal imaged several of the buildings. We plan to do more of that this winter so that we know when looking at the buildings where the leaky areas are, where the red spots are or the hot spots. That's where you're losing a lot of heat. And the thermal imaging helps us a lot in terms of categorizing the efficiency of the buildings as well. The red dotted line shows where current Chicago energy code is. And the circles represent various systems that could be used in a building for each of these categories: HVAC, vertical transportation, plug load, roofing systems, energy generation sources, etc. After we did that, I talked about 35% that we could save on carbon emissions. Where we're going to get the other 65%. One area that we looked at was a strategy for harvesting the power of wind and sun locally, also possibly using wave action, offshore wind farms, cogeneration, photovoltaics, and the Chicago River itself as a source of cooling. That helps a little bit. We also thought about the Chicago tunnel system. Chicago has a network of tunnels underneath the loop that lie about 3 to 3.5 stories below grade and are used right now for distribution of wires and cables to various buildings. But we thought, why not use the tunnel system as a waste handling system and try to introduce a pneumatic system for trash handling, where we could take all the trash to a central point and through the process of a plasma gasification system produce power at that point and eliminate the waste. It condenses the amount of waste to a minuscule amount and use that power to help drive some of the buildings in the loop. EcoBridge is another idea where we build a bridge to finish off the Burnham Plan of 1909, with an arc going from basically Navy Pier to the museum complex, but making it a eco-friendly system where we have a soft edge breakwater. We create space for habitat to be there below grade, below water line. This is an excellent use for local slag that's being produced mostly on the south end of Chicago. It will enhance marine habitat. It'll increase parkland. We propose an environmental learning center, Great Lakes Museum, and in the center, a 600-foot tall observatory so people can get there and look back at the city, and they'd pay to do all that. Other carbon reduction strategies that are regional, not local, renewable energy sources such as biomass, wind, solar, water action, geothermal, and the non-renewable energy sources of nuclear, which could solve a big part of the problem for 70 to 80 years if we needed to do that versus everything else we're talking about. So a larger idea for Chicago's central area has come out of this study, which we call the urban matrix. And the urban matrix is an attempt to actually increase the density of the center city of Chicago and at the same time bring in a lot of residential, hopefully reducing commuter time and reducing the amount of pollution created by cars to get it down to a desired area equivalent to many of the European cities that you see at the bottom of the scale. So within the city, we're proposing that we create a series of walkable districts that are less than 5 minutes walk on grade, and that we have parks, schools, and amenities such as grocery stores, basic necessities, district cooling for each of those areas, so that we distribute a very high quality school system into the central city. And the idea here is that that would help to draw residences back into the city. And it would also help to make the city a more livable city. So the first step might be to do the school system at Lakeshore East, which already has a site for the school and has already been planned for, but hasn't been implemented yet. The next step would be to add another site, perhaps on the southeast corner, where we have a lot of university housing already, and then so on until we get to 50% and 5 schools. And the growth pattern that you see here, the yellow and the red, represent in many cases mixed use, in some cases all residential buildings, some cases more office space. But the idea is to create a very strong mixed community, not just a district of office and a district of residential. Potential building uses like the Manhattan building here would be a great use for residential. The top of some of the buildings on State Street would be great parks, and the top floors of those could be terrific school locations for K through 12. We know that it would enhance the marketing of the vegetation in the city, and we think that parks and gardens, vegetable gardens, could be placed on the tops of many of the roofs. We know that this is not inexpensive. We know it's a cost. We have to redo the structure of many of the roofs of these buildings, but it would actually be marvelous to be able to look out and see roofs of green. We also think that by bringing in more residential and getting a better mix of 50-50 and having many more people walk to work and bicycle, we could reduce some of the lanes of the roads and turn them into greener spaces and mini parks and play areas. We also think that the below-grade walkway system, which exists in Chicago to fits and starts, should be completed and connected completely. This would then create, there's one other thing which is called the Monroe Street transit system that goes from the trains on the west to Millennium Park on the east. That has been called out to be built in the 2016 plan of Chicago. So this would help to build it, and it creates more space on the sidewalks and makes it a more mixed-use community and a more livable community. Examples of some of the other mixed-use buildings that we have done around the world, and some of which could be appropriate here, would be, this is Parkgate, a 4.5 million square foot mixed-use complex proposed for Dubai, and the Burj Dubai building I did the design of when I was at Skidmore, Owings & Merrill. This is a mixed-use building as well, as you know. One Park Avenue in Dubai is also a mixed-use tower of 113 stories. Again, in the proposal stage, all of these projects have since stopped. One Dubai, which is a composition of 3 towers, again with vertical mixed-use components, and in this situation the bridges are intercommunication floors as well, and the bridges would actually contain some of the restaurants and some of the food service and some of the convenience stores and laundry facilities for this 12 million square foot building. There's also an urban matrix which could be developed with a cluster of buildings, both new and or existing, which we have looked at in terms of doing a grid that connects these buildings and then having green gardens within them. The next component we think is very important here, it's critical, is the community engagement process. And we would take a page from Daniel Burnham's book and establish a new WACR manual for this decarbonization plan, where effectively the WACR manual for Plan of Chicago was written as a Chicago textbook and taught in all civics courses for 5th grade students from 1911 to 1928. And it was through that educational process that many people were brought to the awareness of the Plan of Chicago, and I believe that that was a major influence on Chicago's being able to implement as much of the 1909 plan as possible, as they did. So we're looking at buildings, urban matrix, mobility, which I haven't talked about because of time, smart infrastructure, which is another area which could save some energy, water, waste, community engagement, and energy, and then funding. We have some ideas on funding. We need a lot more ideas on funding. This is obviously an extremely costly venture. We could see this as a 10-year plan, or we could see it as a 50-year plan. And we developed a carbon countdown that goes through each one of those aspects and allocates energy savings to each one of those 8 initiatives. So thank you.